Hello and welcome. What we're going to do in this particular segment, I'm just going to move this around here to get out of our way. What we're going to do is we're going to take a look at converting a schematic diagram into a wiring diagram, and then we're going to do a single line diagram count so we can actually start to look at conduit fill from this. So it's a very useful exercise because our schematic diagram shows us what is the function of the circuit, how it works, and the controlling mechanisms. When we get into the wiring diagram is the physical representation of the devices and in relation to everything. And then it actually shows where the wire goes. But it's very difficult in a more complex diagram or a complex circuit to be able to determine the functionality of it. So what we're going to do is we're going to take a look here, and I'm going to use some colors because that's the best way for us to be able to identify these things, to be able to see them. So if you do come across having to do this kind of conversion, please either use letters, numbers, or colors. Colors is usually what I recommend. So I'm going to choose a nice distinctive color, and I'm going to just take a look at this segment right here from our line 1 to our 95. Now the 95 is our overload contact, and this would be an IEC type of contact or an IEC type of control. So this here would represent the left hand side is where you would find those in IEC. If it was in a NEMA, our overloads are typically found on the right hand side. So any which way, it's a series component, meaning that if it opens in there, it's going to de-energize the whole circuit. So it's kind of like our safety stop. Okay, and I'm going to just take a look in here where that happens. There's my 0.95, and I'm just going to trace this up here. And that one is, if it's in a NEMA style starter, this one is pre-wired. If it's in an IEC one, we have to complete that wiring. So I indicated that with the red. I've indicated on the drawing with our red. This stays within the motor contactor itself. Okay, I'm going to move on, and we're going to take a look at, I'm going to use yellow here, and I'm going to make that a little bit thicker this time to be able to see. So now I'm going to go from the 96 over to my emergency stop. Notice how we're flying and we're traveling in on the left hand side. That's how I want to try and relate this in our wiring diagram. It doesn't make a difference electrically, but it does make a difference with us being able to see it properly or not. So on 96, I'm going to go from here. I'm going to follow this conduit path right up here, and I'm going to go all the way over here, and I'm going to just wrap it around as soon as my computer allows me to. I'm going to wrap all the way around, and I'm going to come in on the left hand side. So my emergency stop from 96 out to the emergency stop, I've completed one piece of the field wiring. Now I'm going to move up here to select a different color, and I'm going to choose orange, and I'm going to make it nice and big as well. And I'm going to go from my emergency stop to my stop 1. These are labeled stop 1, stop 2. So I'm going to be very careful about making sure that I follow this diagram. So I'm going to the correct one first. So I'm going to go all the way over here. I'm going to leave a pigtail of this. Now, some specifications are not going to allow you to do field connections like this, but in most situations, this is going to ease some wire count if necessary. And I'm going to go to our stop. Okay, so all I've done is I've just pulled a chunk of wire through here, conductor, and then to our stop 1. That's it. That's where that goes. Now I'm going to take a look over here, and I'm going to choose another distinctly different color, and it's going to go from our stop 1 to our stop 2. I'm going to go from the right hand side of our stop 1. I'm going to flow this all the way down, and I'm going to be able to go into here. If I needed to, I can make a splicer connection in here. And in this case, I don't need to, but I'm going to go over to here to the stop 2. Again, I'm flowing from the left to the right through these devices. because I want to try and interrupt that current from the left to the right. Again, it's just easier for us to do this analysis in this way. And I'm just methodically working my way from left to right through this circuit. And now I'm choosing a different color, and I'm going with purple here. And I'm taking a look at all of the things. This conductor here is all the same continuity. It's all connected, and it's going from the right-hand side of our stop 2. It's going to the left-hand side of start 1 and the left-hand side of start 2 and NEMA 13 or IEC 13. So all of those locations. So the first thing I'm going to do is, because this is internal in the box, I'm just going to run that over there, and that is this one right here. Check. Okay, I've completed that piece of wiring. Now, from that same location where I started, I'm going to go up this conduit. I'm going to go into this junction box. I can make a splice, and this one I would recommend we do, unless there's specifications that tell us otherwise. And I'm going to run this up, and I'm going to come into the left-hand side of our start 1. That same thing, and I'm just going to put a check mark up here. I would recommend also putting check marks to the stuff that you've already built. We haven't done it before up here because they've just been single conductors, so that hasn't been that confusing. But when we get down here, now all of a sudden I have the 3 paths. We want to make sure that we're doing all of those. I've done 2 and not the third one. And the third one can be from any of those locations, but I've left myself a connection point in this junction box. I'm going to run this over here, and I'm going to make that connection to 13. So if I follow this all the way back from 13 all the way back, it's going to the left-hand side of the start. It's also going to the right-hand side of my stop 2. And it's also going all the way to the left-hand side of my start 2. So it's making all of those connections right there, and I haven't had to double up any of the wiring. Okay, now I'm going to go to the other side of the start buttons. And I'm going to choose to use a blue color, and I'm going to do the same thing. From my start 1 all the way to the A1 is one color, and it's the same potential over here. This one is now going to also make that connection to the IEC 14 and the right-hand side of the start button. So I can start any which way. I'm going to start with start 1. I'm going to bring this guy down into my junction box. Now, because there's a lot of space occupied already in that junction box, I'm just going to put it to the side here a little bit. At that same point, I'm going to be able to run this down, and it's going to go to the start 2, and this one is going to follow all the way back. I'm going to do a little crossover here. We can clean this up later if we needed to, and I'm going to go back to NEMA 14. So I now have all of those connections. Now, the one piece that I haven't identified yet in an IEC starter, we're going to have to throw this chunk of wiring in here in our device itself, in that motor starter right there. Okay, and that gets us to A1. So let's just double check from start 1, back, check. From start 2, back, check. And from IEC 14, that's our holding contact, check. I've got all the segments of conductor in there. And now the last piece that I haven't popped in there yet would be my motor control unit right there, that relay for the contactors. And I would just make that little connection up in here. Again, if it was NEMA, I don't need to do that. Those are pre-built. But if it's IEC, we do need to include those chunks of wiring inside of that motor control cabinet. So now what we've done is we've now converted this schematic diagram into our wiring diagram, which also can be now a single line diagram, because now I can count up the number and the chunks of conductors in here. So let's just look at conduit A. I now know I have the purple, the blue, and the yellow in there. I have 3 conductors in this one. This is what we would call a 3-wire circuit, 3-wire control circuit. In B, I have 1, 2, 3, 4. This is where it starts to get a little bit confusing because I have more than one start-stop station. I will start to see some increased numbers here in the field wiring. If you see this, it's the one that we ran to first will always have the highest amount of wire count into it. So when you are looking at your efficiency for wire usage, always do this one as your shortest route because it will use less wire. In this chunk of wire here, or this chunk of conduit here, I now have the orange and the yellow. I have 3 count, or sorry, I have 2 count right there. Let me just make that a little bit more clear. Okay, I have 2 wires running in that conduit. And down here, I have 1, 2, and 3. So now if I wanted to, I can remove all of this stuff in here. Let me actually choose the eraser. I can remove all of this in here now, and I'm just going to be left with just what we started with my wire counts. And I can start to do something that we often see in the field, and that's just by using ticks. 1 and 2. Those are going to be talking about my conductors that are going out to this device. I have 2 wires in here. Now, if they're going to be a hot conductor, I use a dash that's a hot or a switch leg. Or it's going to be a large, long one if it's an identified or neutral. We're not going to see, oh, that one is crazy. We're not going to see a neutral in a lot of these. The only one that's going to require that second one here might be our load devices. So we don't usually see these in our controls, but we might. So that's where we're going to see, is it a long dash or a short dash? That's what it's representing. So over here now I had 4 conductors. I'm going to see 1, 2, 3, and 4, knowing that they're going to be 4 hot conductors. Those should all be the same length. And then same thing here, 1, 2, 3 conductors. Over here, I've got 1, 2, and 3 conductors, all the same length. From a field standpoint, this on the print, I've just got a single line on my diagram, and I've got 2 dashes on it, meaning I need to put 2 conductors in it. Over here, I've got a single line indicating my conduit run or cable run, and I've got 4 dashes on it, meaning I'd have to have 4 wire in there. On this one here, I've got my single conduit or single run, and I've got 3 dashes. I need 3 wire in that. So this now is an expedient way of doing this to create our takeoffs for wire amounts for conduit fill, so that I can now do the calculations based off of section 12 if necessary. What size conduit do I need? And that is it.